Again to a RHEA Talk. This RHEA Talk today is about digital continuity. I am very happy to be accompanied by some experts from Europe on this one, as I said. Before we start, for those that do not know who and what RHEA is, well, RHEA is a space and system and security engineering company. And as a tier one trusted source, we provide our services to agencies, organizations, and companies, which often are those active in critical infrastructure ecosystems. So that's really what we are. For us, it's very important that digital engineering, digital continuity is embraced by us as a provider, but also by our customers and organizations to be resilient for the future. So if you allow me, I will introduce briefly our panel. So first of all, we have Sam Gerené. He's the competence area lead for concurrent design and MBSE and digital engineering, actually, in the RHEA group. He's also the father of Comet, our MBSE and concurrent design flagship tool from RHEA. And he is also, in his spare time, so to say, developing some open source software libraries, for example, Calliope, which you can find, if I'm not mistaken, on GitHub, something like that. Yeah. Next to Sam, we have Alex Vorobiev. Alex Vorobiev has been a colleague of mine for the last 10 years, for sure. And he has been focusing on building solutions, software solutions for MBSE challenges. And in the recent years, he has moved up in the organization to actually manage not only a project, but several projects, so more a program related to MBSE again. He has an aerospace engineering background, and his passion is software development. When Alex and I met, I know that he was in the evenings, actually at night, building software as well for other reasons and for other purposes. So he's a real addict, so to say. Next, Marcel Verhoef. Thanks, Marcel, for being here. Marcel holds a PhD in computer science of the Radboud University of Nijmegen in the Netherlands. He's currently working at the Concurrent design facility in ESA, and with particular focus on development of information technology. I'm having to read this from a piece of paper because this is too long for me. With particular focus on development of information technology to support concurrent engineering, and is secretary of the MB4SE advisory group and co-convener of the ESA MBSE workshop series, and technical officer of several ongoing R&D activities on digitalization of engineering within ESA. So a big mouthful.
Sorry about that, Arne.
Yeah, I think it actually summarizes perfectly with what you are, what you do. So that's good. Then we have Hans-Peter de Koning, 35 years experience in engineering of complex systems. Met more than 10 years ago, I think, Hans-Peter, while working together with ESA, where he was working until a few years ago, when his career at ESA stopped on his own, well, for your own reasons. I think you went on pension officially, from ESA. So Hans-Peter is, he has a vast experience in developing an infusion of international standards related to MBSE, so standards, tools, and methodologies. In particular, especially when he was also at the ESA CDF for concurrent engineering in early phases of spacecraft missions. He has a Master of Science, Applied Physics from Delft University, so the Netherlands is well represented here. And several say that he is the guru of SysML. I leave that for the audience. Last but not least, Gianmaria Bullegas. So welcome, Gianmaria. Gianmaria is a bachelor and master degree in aerospace engineering from the University of Pisa, which he quickly followed up by actually getting a PhD. And after this PhD, became the CTO of Symbiosis Ltd, which you traded in to actually be the founder or co-founder, I don't know, in 2019 of Perpetual Labs. And as you provided me with your small bio, the rest is history on that front. Huh? So thank you very much for being here. The audience is very pleased with having you. They will ask questions at the end, and there will be polls popping up during the sessions. So let's start. So Sam, for the uninitiated, can you give an overview of what digital continuity is and how it is helping our clients?
Yeah, thank you. Digital continuity has I think many different definitions. So I can give you one that I typically use, and I'll sort of allude to how we help customers achieve digital continuity. And maybe a good way to define it is actually to start by explaining the problem it's trying to solve. So when we are in engineering of complex systems, that's typically where we work, at least where I work, and RHEA works. We deal with a lot of stakeholders, not only in one organization, but across multiple organizations. Also over time, given the fact that the design and development of a spacecraft or a space mission takes anywhere between 5 to 10 years, especially if you think about large institutional space missions. So you can imagine that there are a lot of challenges that we face by making sure that all the stakeholders inside, across organizations and over time have a good idea of what it means to be that system or that system of interest. So we have to write down descriptions of what it's supposed to do, typically in the form of requirements, and how we aim to achieve that, and then design it in the form of a solution. And of course, the amount of information that you create over time grows and grows and grows. And what we're trying to achieve is that we can easily, and it's not easy, but easily sort of exchange information between all of those stakeholders, again, across disciplines, inside organizations, over organizational boundaries, and across the lifetime of a space system. And I started by saying that it's only for the design, but of course also when you operate the system. So it's not only about those 5 to 10 years to lead to a launch of a space mission, but then also potentially 5, 10, or 20 years of actually operating that system and using it, and also disposing of it at the end. So a lot of data, a lot of information that we're trying to share amongst each other. And instead of trying to do that in document form, which we've done and many people still do, which is very challenging as complexity grows, to still make sure that you're on, let's say that everybody's on the same page, literally sometimes. We try to do that in a digital form and make sure that we then achieve digital continuity. So making sure that everybody has access to the right information at the right time, contributing it, etc. So a big challenge. So I don't think I gave a definition of what it is, but try to explain what it is by sort of telling what problem we're trying to solve, or let's say the challenges that we face. Some of those challenges we've actually managed to deal with, and with pretty good success, especially in the early phases. Granted, that's the easy part of it, I would say. And together with ESA and other organizations, RHEA has managed to develop tooling to actually support that, and also train people to then make best use of those tools to achieve that goal of digital continuity for a very limited period of time. So early phase design, typically in the context of a concurrent design facility or concurrent design study. So we can exchange data amongst all the disciplines, both users of the system and people that come up with a solution, to actually express what it means to be that system, and make the best of it. And then of course you want to hand over that data to people who may be the same, but who might be different, also in a different organization, that then evolve that design as you come closer to launch.
Okay, Sam, thank you very much. Actually, what especially at the end of what you said, it actually makes a bridge to a question that I wanted to ask Alex Vorobiev. So Alex, within RHEA, what specific activities are we actually doing and have we done in relation to MBSE?
Yeah. Hello, everybody. In the last, for the majority of the time in the last 10 years, we've been very active, just as Sam mentioned, in the field of early phase design and building tooling to support these processes. Our main focus has been in the ecosystem of ECSS ETM 1025, which is a technical memorandum describing data structures for space system data exchange. Using that as a common base to build a myriad of different tools, open source tools, in collaboration with both the European Space Agency, other national agencies, and private partners in the industry. For example, last year we have worked on a number of different projects. One of which was called Digital Engineer Hub Pathfinder, in which we built quite a large number of integrated tooling to allow you to exchange information, not just with our main concurrent design tool, Comet, but also with other MBSE tools like Capella, Enterprise Architect, and Magic Draw, and so on and so on. We also had a look at generative design and worked on something called generative concurrent design, allowing computer processing to take an initial concept, an initial model, and produce alternatives based on some specification. And again, integrate the information exchange with the platforms that RHEA builds. And more recently, we have begun close collaboration with the European Space Agency on development of what's called the space system ontology, which tries to conceptualize all information items and entities that are relevant to space system design, and then a prototype tooling software that will allow us to actually use this for information exchange. So really finding or trying to solve challenges that we currently have with interoperability between different tools, different data models, and so on.
Okay. If you have anything else to add, feel free. But I didn't want to interrupt you. I was just very happy with what you said. So.
No. So over the last years, what I would like to highlight is that RHEA has been very active in the open source field. So a lot of the results of our projects we very much are trying to share with the communities, with our partners, and invite also contributors to the software that we make to actually be available as part of
Thanks, Alex. So again, here a nice bridge to Marcel, because of course, Marcel, you know, a lot of the activities that we do, R&D related activities, we do together with ESA. So question for you. It's a very sort of heavy question, maybe, so you don't have to go into the details, but what is the high-level strategy of ESA towards MBSE? And a related question, how far are we away, and I say we, but the ones that work with ESA, for example, from full digital continuity?
So these are indeed extremely challenging questions, Arne. So to start with your first question about the strategy of ESA. So in the end, we have to remember that the digitalization is basically intended to improve communication and to improve collaboration. So in the end, we want to make sure that we do things faster, but keeping the same level of quality or even better, and doing it at less cost. So that's the overall aim why we are interested in digitalization. So that is an enormous, difficult change process, because it's just not a matter of trying to do things digitally and then think everything will work. It is involved in all the processes that ESA is involved in, and not only within ESA, because we are basically an entity that is in charge of procuring new space missions, but also with our partners in the field. So the entire ecosystem, the space ecosystem, has to evolve. So also our suppliers, the large space integrators, they are working on digitalization, and also their supply chain underneath is going towards digitalization. And all this has to work in unison together. So this is the big challenge that we are facing together, and that we as ESA are trying to coordinate. So that's also why we've established this model-based advisory group for model-based systems engineering to try to coordinate with the LSIs, but also the other space agencies and some other stakeholders to make sure that we're on the right path. So we are setting up a roadmap to identify what needs to be done and by whom and in what order to evolve together to make sure that digitalization happens. So that's basically the long-term aim that ESA is looking for. And that is not a smooth path at all. So to answer your second question, how far are we away for it? Well, I think if you look at the adoption curve, which is typically shown as this hockey curve, you know, and we are still on the going up in the curve. So we are trying to digitalize everything, and we're still learning every day what to do. And we are now trying to see the consequences of this. So when model-based engineering approaches are being adopted, we first have to overcome the hurdle of the people that are challenging us, because why do we need to change? Why do we need to change the current way of working? What is the benefit in the end of the day for this activity? And as with any technology introduction, the discussions on return on investment are extremely hard to make concrete, because it's a soft element. It's not just the digitalization that plays a role. As I said, it's part of an overall process. So you're changing a very small part of the entire progress, but it has big consequences overall. So a lot of the return on investment discussions fail. So the only thing we can do is to show by example. So we start small and we try to make some gain, and then we try to increase our competence and also the impact that we gain. And the strange thing that is actually happening is, as soon as you're trying to achieve some good results, people are seeing the advantage of it, and then they turn it around. They are going to use that as leverage to stop others to use the same technique, because they can see the competitive edge of the opening up and the integration of digital information. So when we are moving from documents to models, one of the things that happens is that we are getting more competent. There's more information involved in these models. So our knowledge is actually captured in a better way in these models. And these models become our intellectual property. So why should I share my intellectual property with one of my competitors that may be downstream or upstream from me? So these questions really have a big impact on it that have nothing to do at all with technology. And it's the same discussion that we now see about information security as well. Is the approach now that we do open innovation together in the chain, or are we restricting ourselves because we want to have a European incentive being focused and making it better compared to what we do in the US and Japan, for example? So this is what making the rollout of digitalization extremely complex. It's not at all a technical issue. It's an organizational issue that is addressing change in the organization. And the tools that we provide are just an enabler to do that. So that's, I think, the main challenge that we have to overcome. There's many sides to this that I haven't mentioned even before, but basically, a lot of people are not really aware that this is the side effect of digitalization. It starts with training people, getting the tools in place, finding the methodology, hooking it up in your business processes, making sure that upstream and downstream users are also able to talk the language. When we are talking across disciplines, we have to also bridge the gap of speaking different languages, literally, because a system engineer and a thermal engineer and a mechanical engineer do not speak the same language. So when we start digitalization, we also need to make sure that these people understand each other when we are trying to connect models. And actually, to make it really even worse, there's even not a consensus of what a model actually is from all the domains. So we have a lot of work to do to move everything forward. But nevertheless, the output of it is that we do improve communication, because the fact that we didn't do before is already shown by the fact that we do digitalization, but in the fact that we are talking about this right now.
Okay.
So I hope that sets the scene a little bit.
No, Marcel, thank you. No, very, very good. And I know from experience in specific contracts with ESA or developments with ESA that some of the things that are, how do you say it, highlighted is, for example, the contractual side As you said, the business processes, contractual side sometimes requests documents to be delivered, while actually in the future we want to deliver models, for example. And that is, so it touches on what you said. So thanks very much. It also opens, because you mentioned a lot of challenges. It opens the question that I have actually for Hans-Peter. He's been in this topic for 35 years now. So Hans-Peter, we have challenges, but what do you see as the most important enabler to actually achieve our goal of digital continuity?
Yeah, well, just like in the systems, the complex systems that we try to develop, where interfaces are one of the most important things to get right, especially from a systems engineering point of view, because it's the way you connect all the different components or modules or whatever you call them in order to get a whole that is better than the parts. It's the same thing with the whole development environment or the supporting environment in the digital world. Let's say all the computer tools and the digital models that we use in order to do our job, they need to be integrated, and the key is to get the interfaces right, because it's very difficult to get integrated tool sets, because just by nature we need to integrate so many different things from different companies, from different disciplines, as Sam said, over the life cycle. Over time, is also for archiving in order to make the connection with knowledge management, with building up the knowledge, the company knowledge, learning from it, reusing models from successful projects. All these kind of things, they need working interfaces. And because we cannot rely on a single vendor or or even a small set of vendors or tool developers to get all this integration correct and working, I think the only way forward there is to have standards, just like we have on the web. The whole World Wide Web works well because we have some really good underlying standards that scale, that allow you to connect all these different pieces of the internet. And that creates an ecosystem that allows you to advance and to master the complexity that we need. So the word ontology was mentioned. So we need interface definitions and protocols that carry the semantics or the meaning of the data, because that is needed in order to connect all these different machines and to create a kind of giant plugin architecture. What is also very important, I think, is to look at the role of and the best combination of using humans and machines together. So the machines and the tools, so the computer tools, should really assist and enhance the capabilities of the human engineers in order to do their work well. And so that is another aspect of digitalization and digital continuity. Because we want a system there where, let's say, the creativity and the fast, more intuitive and gut feeling of the engineers is enhanced by the possibilities of digital tooling to master very large sets of data, like you have now in machine learning, and also in the current applications of AI, which is basically nothing else than a giant bookkeeping machine that is very fast in searching and combining indexed data and making that available so that the human engineer can do their work better. One aspect of it is also there's a lot of emphasis on model-based systems engineering or model-based, I don't know what. Of course, that is nothing new. All engineering has been using models for the last 50 years. Mm-hmm. Only systems engineering was one of is maybe the last discipline that's actually starting to use models in a proper way. So that's another aspect I find very interesting. This is also something that is sorry, I had to stop a phone call. This is also something that is that came up when we started with the MBSE developments at DEKonsult around 2005. At that time, the term model-based system engineering was coined, but we said immediately the sooner we get rid of this MB in front of system engineering, the better it is. Because it should be natural to use models in systems engineering as well. Yeah, that's more or less what I wanted to.
Hans-Peter, a question there, and I'm not sure whether you touched on it, but we have to, of course, humans and the machine and the models, the digital models, the user interface, and to interact with complex. Our generation, whatever, is still used to writing things down and drawing, but interacting, and we know it from our own developments. Is that a better interaction with, or more intuitive interaction with digital models? Is that not an enabler that we also should very much look at?
Surely, yeah. I mean, clearly the user interface or the user experience, as it's sometimes now called, is very important. And like any tool, let's say a tool becomes productive when it's well adapted to humans. And with a computer tool, there's nothing different there. And we all know, you know, our favorite computer tools that have a nice flowing interface, and we also know a lot of tools that are clunky, difficult to use, etc. It's sometimes very difficult to pinpoint why a particular tool is not easy to use. But one of the clear measures is the number of clicks. For instance, the number of mouse clicks you have to do something that's relatively simple. Or you know, the time it takes to find something, the kind of views that you are able to generate or to display on a screen or even on a set of big screens. So there is clearly user experience or user interface design is a very important part of making good tools.
Okay, thank you, Hans-Peter. So Jan. 2019, you started with Perpetual Labs, huh? Not for no reason. You must have had a vision behind that. We've mentioned open source already in the beginning. We mentioned open engineering. So for you, what does it mean to build an open platform? And does it mean that we have to put everything in open source?
That's quite interesting. And actually, on that question, I would like to echo something that both Hans-Peter and Marcel were saying. And in fact, like the example of the internet, I think is great in showing what an open platform is. The modern internet, World Wide Web, is built on a stack of very simple open standards, and it's open in the sense that as long as you adhere to those standards, you can play, you can put your stuff out there. Doesn't mean that everything that is on the internet is up for grab, that there is no paywall, that everything that you put there is accessible to everybody. No, we know that we have authorization, we have access control, we have paywalls. And that's the difference. The internet is built on a series of open standards and is an open platform, but it doesn't necessarily mean that is free for all. Now, what are the barriers here to building an open platform? And really echoing what Marcel was saying here, what's the system of incentives and in the technology? What are the more economical barriers that are there to move our organization forwards? And again, let's take the example of the internet. Today we are all doing these video call on Zoom, right? And but in my organization, we use a different tool. We use the Google tool, and other organizations use Teams, and there are many other tools, Blue Jeans or whatever there are. And you remember, like back in the day, we used to have protocols like the SMS protocol, like 20 years ago. Why don't we have a video streaming protocol that all these tools can comply with? And then we can have this video call. I can use the tool that I prefer, you can use the tool that you prefer, and we all live happily ever after. As a matter of fact, the World Wide Web had a proposal a few years ago for a streaming protocol standard. So the technology exists. So why don't we have a video streaming protocol standard so that we can all choose the tools that we like the best, and the tools can compete with each other on actually what they're good at, on the quality of the user experience, rather than just putting all their effort into locking you in a walled garden ecosystem as a user. And that's precisely what's the problem. The system of incentives, these companies are not really trying to compete who makes the best video conference tool. They're trying to lock user in a walled garden by not making their tool interoperable with others. And that's how, and that's why they don't want to adopt interoperability standards. So that's how we think about it. We should really think about digital engineering as building a set of foundational protocols, like the protocols that underpin the internet. And those protocols should be open. And then we can build a plurality of tools and applications and platforms that then can work with each other, and we can share data, and that data can be open source, or it can be closed source. But that's the only real way to break the silos of information.
Okay, so as you might know, we're working on we're active also with ESA together on something called the MBSE Hub, if I'm not mistaken. So what you're actually putting the banner up for is to be able to exchange models, but also exchange data between different models through an open standard, and continue from there. Yeah,
let's and the space system ontology is going in that direction, but it's at the very top level. We need to kind of agree on the lower level of that data interoperability stack. And again, there can be, on that set of standards, there can be a plurality of platform. One can be like the RHEA is working on the model-based engineering platform. I hope that they're gonna build it as much as possible on open standards, so that it's gonna be interoperable with other platforms.
Yeah. Maybe Arne, if I can add, because
there,
let's see, I think we share a common vision. And even though the space system ontology is only available inside the ESA community currently, we are building it on current web standards. So not trying to reinvent the wheel or do something that is not standard practice on the web for that particular reason. So when ESA and the community decide, well, actually, first of all, to make sure that everybody inside of that community has easy access and can use the hub for what it's intended to do, is to have semantic interoperability and exchange information amongst each other using those web standards. And then hopefully, and I really hope that we achieve that goal, is that ESA, and it's not only ESA, it's that community together decides to make it more open so that we can also use it to collaborate with sometimes our competitors and sometimes our allies. So let's say when we want to do space mission successfully. So I think we're in agreement, not even violent agreement, let's say very much agreement, and we're doing everything we can to make sure that we benefit from those web standards to make it happen.
Yeah. Just a clarification. I was trying to make an analogy with the web standards. Yeah, in the sense that we should build, like, the web standard clearly don't cover all the needs that we need for digital engineering. but we should try to replicate the model of creating open protocol. For example, we know that we have the need for interoperability of simulations, right? And there is a lot of work on FMI, the SSP standards. That's definitely going the right direction. It's great, and I think that's the right direction. Building open standard like the FMI and the SSP that everybody can access to.
Okay, thank you, Gianmaria. I was just thinking whether it's time for a poll. I don't know whether our producers can pop up a poll. So here's one. So for the audience, I would like to give you a few seconds to think about this poll. So where should we place our focus? Should it be on the people, on the process, the technology, or none of the above? I actually also tried to push one of them, but I see that the panelists cannot even vote. So it's
No, we cannot, because he would probably say all of the above, and that's
yes.
not an option. No, but it will be interesting to see how the people respond to this.
Yeah, exactly. So, all right, what do we have up till now from our results? Okay, so quite in parallel, let's say, the people and the process, the technology. Yeah. Go ahead.
It's interesting to see that some people actually said none of the above. So that raises then the question.
I was thinking the same thing,
right? So, or maybe people think that we shouldn't worry about this at all and just let the world go by.
I think it's AI.
It could be, yeah, absolutely.
We should just replace people completely.
And and maybe like Hans-Peter said, make sure that we benefit from that computer science augmentation that AI can bring.
Yeah.
I would be sad if we are replaced because I enjoy what I do and then I have to find a new thing to go about doing if AI replaces me. Yeah.
Now, maybe it's a good question anyway for the audience to think about that. If it's none of the above, why? Where should we focus on? Should we forget about it, or should we think of something else to focus on to get ourselves into digital continuity? So
perhaps participants can put a comment in the chat if they want.
Yes, there is the Q&A button that is on the top, on the bottom of your screen, where you can actually post questions and answers. Again, we cannot, the panel, but the others can. So please, audience, feel free to ask questions that you want the panelists to answer. I have a few myself actually that I can already raise, and maybe we can have a quick panel discussion. Is how would your digital continuity utopia look like? So Marcel, how do you see that?
That's a hard question to answer, but looking at the current developments that are going on with ChatGPT, it's not very difficult to imagine that the level of support we will get from our tools will be orders of magnitude better than what we can do now, given the fact that we are capturing a lot of these information, but also analysis powers in these tools, and being able to combine that, such that when you are working, you don't have to wait for an analysis to be complete, but you're instantaneously already being augmented with comments to what you're doing. So I don't think that I fear that our jobs will be gone, but I think our jobs will change radically because I think the power of all these tools will enable us to do much more and much better, provided still that we can share the information across without having borders in between, like IPR restrictions, security concerns, and so on. Because if the information isn't there, you simply still cannot do anything. So we still have to address these basic concerns about under what context do we work together. We have to have a basic level of trust and agreement between all the participants in the process in order to allow us to share information across. And then also we have to accept that these tools are actually sometimes better in suggesting elements than that humans could be. And that's also something that I think might be a blocking point. So will people actually accept these very fancy AI tools in their daily practice, or will they resist it because they are feeling threatened by these? So just a few points from my side.
Yeah.
Hans-Peter, sorry, Sam, but Hans-Peter, you're working hard on SysML2, if I'm not mistaken. So how would that get us closer to the utopic, and how would that bring the world closer to what you have in mind as the utopic?
Right. Well, SysML, SysML and SysML2 is particular. The good thing is that it's a worldwide standard, and it's generic across all industries, which gives a kind of economy of scales for the tooling and the language. It's also independent from methodology, so we try to keep it purely as a language and not bias it towards a particular methodology, because the methodology, in our view, should be optimized by the organizations or the industry sectors that use it. But the major new part of SysML2 is a standardized API. So it's a modern API. In the pilot implementation, there are two implementations, but it's a technology independent specification of APIs. And then there is currently two implementations. One is a REST API and the other one is OSLC. And so that gives, in principle, that will help open up the world, so creating more of a platform, let's say a systems engineering platform, where you can connect different tools in a kind of plug and play way. So you don't have to, if you want to connect to a different tool, to start implementing a different API with all the adapters and translations that you need to do, which makes it very complex to develop, but even more complex to maintain, because the real trouble in all these interfaces or the interface implementations rather is the maintenance of it and keeping up with the evolving new versions of all of the tools. So that is one thing. The other thing that on AI, I think hopefully AI, currently AI and machine learning is really simplistic. We should not overhype what current AI can do. It can help a lot. It can find stuff very quickly. It cannot think. Thinking is still the realm of people and humans. Machines really cannot think yet. And maybe this is coming in some years in the future, but the current generation of AI is really not thinking AI. And we have to keep that in mind. So I hope what the tools will do is to create more time for people to think, instead of being busy with manipulating data, getting it from one tool to another, getting it from one discipline to another, synchronizing the data, doing all the bookkeeping, all the configuration, version control, and all that, because that is dumb work that machines can do very well,
and which we've all been doing for ages. That's true. So no, I thank you for that answer. We also have a poll which actually is related to a bit to that, because you said that you hope to bring with SysML and SysML2 a technology agnostic solution with your API. So here is a question related to sharing technology. So again, I would give the people some seconds to look at it, and maybe to the panel, we could look at the question that is in the Q&A, which is the one whether you have an opinion about which sectors have achieved or are getting closest to digital continuity. And why is that different to what's happening in the space industry? And can the space industry learn from that? So I would actually maybe hope that Marcel has a view on that. If not, maybe Sam can also provide. So why don't you try to answer that question already, and then see what pops up from the poll.
So with the limited view that I have, not being involved in all industries at all time, that would be impossible, which is space and defense, and also in defense at a sort of in a limited scope, being on the procurement side in a similar fashion that ESA is on the procurement side. I have to say that the space domain, as I've been working in it, is far ahead of that defense domain, especially in those institutional organizations that are responsible for procurement. So there's a lot to gain, and that's also, I guess, or I'm assuming that is part of the reason why we are supporting those organizations to get closer to that goal and help them make progress. I have not yet worked, unfortunately, in the car industry or in the automotive, but given the fact that they can make new versions of cars and in such big variety, my assumption is that we have a lot to learn from them. But again, it's an assumption, right? Because I've not had the pleasure to work in that industry, but they do something that is really hard to do. And they seem to do it quite well, because I've driven many different kinds of cars, old and new. And they make it happen. I
think one of the complexities that we are facing in the space domain is that we are building one-off products. So there's not a lot of similarity between missions apart from context that we are flying in space. And I think where we will see digitalization that has moved much farther than the space domain are those that are basically product organizations that build things in large volumes where the margins are slim. They need to do this digitally because that's part of their business case. If they are losing money because they are losing effectiveness, then obviously they don't have a valid business case anymore. So I would assume that in those areas, digitalization has progressed much farther. And I can only imagine that, for example, manufacturing related industries, for example, for building chemical plants and so on, that's also highly regulated. So there's a need not only technically to do things, but also to show to external agencies that they do it in the right way. Because if the factory explodes, you have a big chemical pollution, for example, on that, there's a lot more digitalization going on than what we see. So it's a matter of balancing also as well. I think if you are in a very tight domain, you can do digitalization very deep and very far, very optimal. But I think one of the challenges in the space domain is that it's once off, and it's also very broad in terms of the types of disciplines that we need to involve, which makes the span of control much larger. But that's just my take on it from the space domain. Perhaps Hans-Peter can reflect a little bit on experiences from what he knows from the SysML community. But
go ahead, Peter. And in the meantime, the poll results are up. I think everybody sees them. Well,
I'm happy to see there's not too much emailing going on anymore, even though
I was going to say that
on my day emailing still.
Yes.
But
it doesn't reflect in my email inbox, to be honest, that is the case. But
I am surprised by the results on PLM. Actually,
it's very low.
Well,
very interesting.
Yeah.
Nobody from the car industry.
So Hans-Peter, you mentioned that your endeavor on SysML and the future of it is to be industry independent. That's really where you want to go towards.
Well, it's a generic language, because let's say, despite what some people think that everybody has special needs and special problems, if you look at it from a bit of a distance, it's the same problem in almost all industries, and especially systems engineering is a very generic discipline. So there's much more commonality in the problems to be solved than differences, and that is one of the reasons to do it as a single language across all industry sectors. And I think, and also this is also interesting for the tool vendors, of course, for tool developers, because it creates a much larger market in order to develop good tools. And So that is, I think, yeah, the reason to do it in that way, because it's a huge endeavor to develop these platforms and these tools. So I mean, you need really, in order to make it commercially interesting, you need to get an economy of scales on the tools, because otherwise I mean, if you only develop for a single small market, it's too limited.
Okay. Do we have any questions? Does the panel have any questions, for example, to raise to the audience? Something that you are very interested in that you would like to know from our audience? Alex, you're smiling, I guess. You have something on your mind. Sam?
Yeah, the questions are so broad, but what I can think of is if somebody can make a statement on where they feel the representatives of the organizations that we have on the panel today, where we can actually make others' lives easier, that would be interesting to know, because then at least we can think about it. I always, let's say, my assumption is that I have a very limited view, and all the work that we do is in part also born out of our own frustrations, because we had to do work as system engineers. We weren't happy with the way it was going, and we built languages and tools to make our own lives easier. But yeah, we can only do things that are valuable for more people if we also understand better what other people's challenges are. So,
yeah, and Sam, I think that one, and looking at Gianmaria here as well, because you supported, you created in 2019 your own company. Probably
yeah,
also
out of my own frustration.
Yeah, exactly.
It's exactly how it goes usually.
Yeah, exactly. So what was the main driver for that? And I ask you because I'm not so sure how I will get the answer to the question that is not posed in the view of us. So instead of asking the people, I will ask you, Gianmaria.
I'm going to be very practical. For me, the main frustration at the time, I was working in my previous company, which was an engineering company, but like hardware engineering in the context of defense here in the UK. And I started working with Modelica. And I thought that was an incredible tool, right? To simulate my system, not have to worry about the equations and handling all of that. And then I realized, okay, why there isn't a large scale library of models of components of real physical system, as in I'm developing my system, I need a motor, an electric motor for a robotic arm. Why can't I use, why a supplier, a producer, a manufacturer of electric motor doesn't have a digital twin, a model packaged as an FMU, and I can go on a catalog and import it in my model and test it. That is already calibrated with all their experiments, and so I don't have to know, I don't have to have access to their design, I don't have to have access to their data. I just take this thing as a black box, import it in my design, test that it works, and then I can order it from them. And I was gobsmacked that such a thing didn't exist. And that was really the spark to start a company.
Okay. Well, very clear, thanks. Hey, I see that there's no further questions also for the audience. I don't think we have any more polls either. So even though we're, 7 minutes before the official end, well, there's one popping up. So let's try to catch that. Does there have to be something done in education to achieve this? So touching on that, we all have, well, several of us have had an aerospace engineering education, as we have learned from the bio that I gave at the introduction. So what should change there? Hans-Peter?
Well, training, of course, is very important. So tutorials, training should be partially built into the tooling itself, but also you need, I mean, it's a vast subject, and let's say I know from my own experience that teaching how to use these systems and convincing people to use them in an effective way is a real endeavor. You have to really invest in that, and it won't go by itself. So clearly training and especially also having good examples, so examples which are not too simplistic but also not too big to teach, are very important.
So Hans-Peter, on that one, I know that RHEA is in touch with several universities to see how we can actually provide with our tooling to them and also training to them to ensure that the thinking in models is already in the system engineering classes. Gianmaria, are you also involved in supporting academia, educational organizations to help to boost the model mind?
Well, we're not directly involved in education, but we are collaborating with several academic institutions on academic research, and I mean, hopefully that is gonna kind of percolate to the teaching, and also our contribution is to try to make a lot of this stuff, like Hans-Peter said, having examples that are not trivial. It's very, very important. So as much as we can, we hope to put everything outside and open source so that people can access it and play with it themselves, which has proven to be very effective for the software industry.
Yes, exactly. And so now to close, before closing, I want to give Marcel also, as a representative of ESA here, is ESA has an exemplary role, if that's the right way to say it. So
yes, indeed.
Are you involved in the education?
Yeah, absolutely. I think we have actually an education office which is focused on doing this kind of thing. And we are organizing actually every year now a system engineering challenge. And there's also a CubeSat workshop as well that is hosted at ASEC in the Galaxia in Belgium, where we basically preach the religion of concurrent engineering using all the tools, and they are exposed to these techniques as well. So we're trying to train young engineers already in a model-based fashion. But I think what is really lacking is in our educational systems is that there's no a university education on system engineering as is, because we're all organized according to the usual silos. So you've got a department of mechanical engineering, department of electrical engineering, department of software engineering, but there's no department of systems engineering yet. I must say, I think this is changing. So I think what we're also trying to do is to help other organizations, such as, for example, TNO-AC in the Netherlands. They're collaborating with CERC in the US to set up a real teaching line and academic track for doing systems engineering. So that will take probably a decade before it becomes maturity in university surroundings. But I think this is the way to go. I mean, you can see from companies like MATLAB that have been pushing their tool into academia and the mechanical engineering division a lot. So all the students are trained with it. They come to the companies, and the first thing they ask to their boss is, "Where's my MATLAB? Because I can't think without MATLAB." I mean, this is the way to go. So we need to make sure that at universities we try to teach students how to use it. So when they go into industry, the first thing they will ask is not to open the Word document, but to ask, where's my tool to do things model-based? So I mean, that's obviously the solution to the problem.
Thanks, Marcel. I think it's a perfect end to the session. I hope everybody has enjoyed it. From the audience, I would like to very much thank the panelists. It's for sure not the last time that we will see each other. So looking forward to the next meeting, and also for all the people in the audience, keep an eye on the next announcement of the next RHEA Talk. The topic that it will have escapes me at this moment, but you will be informed, and I hope to see you then. Thank you very much, everybody.
Bye-bye.
Thank you, Arne. Thank you, everyone.
Thank you.
Bye-bye.
Bye-bye.